Okay, practice number 1. Bookstores specializing in selling used books award different amounts of points to customers who supply them with used books. The points are used towards the purchase of other books in the store. Sorry about that. Book traders list and point values in a table, and Round the Block Books uses a point to post its point values. So we got two different stores here. Book traders reward books, given their information as a table. Round the Block Books given to as a graph. So we want to go through like we did in our notes today, label each column in the table and label X and Y axis the appropriate quantity. So one more time, the first one is always your independent. This is your dependent. Now in this case, we are talking about the number of books you turned in. And based off the number of books you turned in, you get the points earned. On the graph, same thing happens. X is always your independent, which in this case is the number of books. And the Y is the dependent, which in this case is the points earned. Okay. Letter B. Compare the slope of each function and explain what it represents in the context. So back to slope that we've been doing on. For the first one, the table, I'm looking to see here if it's how it's increasing from one y to the next, and noticing that on the x's it's doing the same. It's going by +2s every single time, so nice and consistent there. And then on the y's it's increasing by 12 each time. So therefore, for part B, I'm going to write it down here. Part B, the slope of table is y's over x's, so 6. So what that means is 6 points per one book. On the slope of graph, I'm looking for nice points to go from one nice point to the next. So I'm trying to show that staircase. And as I do that, nice point here, 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 man, I got a lot of nice points going there. So I'm looking to see how much I'm going up and how much I'm going over. Looks like the y's, you're going by 5s, okay? So I'm going up 5, and I'm going over on the x's are going by 1s. So I'm seeing that up 5 over 1 to make that nice staircase we keep talking about. So changing the y's over x's. So this means 5 points per one book. Okay. So compare the slope of each function. So when I compare these, I'm going to say then this is greater than the other one. Okay, 6 points per book is greater than the 5 points per one book. So right now, book traders reward points has got a better thing going on than say the graph, the Round the Blocks book. On part C, compare the y-intercepts. One more time, y-intercepts occur when x is 0. Now when I look at the table, I don't see that x is 0, but let's think about that. In the context, this problem means turned in 0 books and earned, well, if you turned in nothing, you're not going to get anything. So the y-intercept on both of these is equal. Y-intercepts are both 0 and therefore equal, okay? Because when I look at the graph, the y-intercept occurs when it crosses the x-axis, which is right there, which makes sense. 0 books, 0 points, okay? All right, and then we ask you to do review 3AB. That's the stretch, review 3A and B. Write a recursive formula for each sequence. So we got to figure out how we're moving from one to the next. So 3 to -6, and then continue with that on. Now 3 to -6 should kind of jump out at you, times 2, but more specifically times a -2. I'll write this right below that. Is that continuing to follow on? Times -2 times -2. That's looking good. Now, the recursive formula on those. Let's go back way back then on the recursive formula. For letter A, this is first off called a geometric sequence because we're multiplying by 2. So the common ratio is what we call that. Ratio, not ration, is -2. So the recursive formula looks like this, where you take the previous one and multiply it by the common ratio, -2. That is the recursive one. Now, if it asks for the explicit, which we've been focusing more on that is where you tell me the first term, that's a G sub 1, and multiply it by the common ratio to the -1. So we're starting off at 3, common ratio is -2, and this is then the explicit formula, and this is the recursive. Technically, they only wanted the recursive, but it's a good point to talk about it. Same thing's happening in letter B. From 180 to 160, 140, I'm subtracting 20. So what that means is we have an arithmetic sequence, and then saying we have a common difference, which in this case is adding a -20. Now again, they want the recursive, so the recursive one looks like this, okay, where D is representing what we have, and we just keep adding a -20 onto there. Now, that is, again, the recursive formula. So just keep taking your terms and keep subtracting 20 off of that, okay? But what we've been focusing on more is the explicit formula that looks more like this. So just because we can, got to know the first term, which was 180, subtracting that 20 to go from one term to the next. So I myself like the explicit formula, but technically they wanted the answer for the recursive. Make sure you can really kind of do any of those.